Hello all, in this video we are going to learn about Apriori algorithm. Apriori is a classic algorithm used in association rule mining. It determines and it identifies frequent item sets in a transaction database and derives strong association rules from them. It works on the principle that all non-empty subset of a frequent item set must also be frequent. These are the steps whenever we want to apply a priori algorithm. First one, initialize. So scan the database to find all frequent item set. Then second step, generate the candidate item set. So use frequent k minus 1 item sets to generate candidate k item sets using the join step. Apply a priori property, prune the item sets whose subsets are not frequent. So that's a second step. Third, count the support. So scan the database to find the support count of the candidate k item set. Fourth one, frequent item set selection. Keep only those item set with a support greater than equal to minimum support. Minimum support will be given in your problem statement. Repeat, continue until no new frequent item sets can be generated. And the rule for generation, we always have to remember, from frequent item sets, generate association rules that satisfy minimum confidence, that is nothing but the minimum support. So these all are the 5 steps: initialize, generate candidate item set, count for the support, frequent item set selection, and repeat. And then at the end we will get the rules, association rule between the item set. So let us check with the help of example. So find the frequent item set using the candidate generation. We have to use a priori algorithm over here with minimum support as 2. Minimum support will be given in your question. It can be 2 or 3 or 4 and 5, and there will be number of transactions. Either it will be 6 or 7 or 8 or 10. That depends on the question. Over here right now we have considered 6 transactions with a transaction ID starting from T100 to T600, that is a transaction ID, and we have the items like I1, I2, I4, I5, I3, like that we have the items. So you can see in the first transaction, that is T100, we have 3 items purchased by the customer, that is I1, I2, I5. In the second transaction, which is T200, customers has purchased 4 items like I2, I3, I4, I5. Similarly, in the sixth transaction, that is T600, customer has purchased I2, I3, I4 and I5. So that is how the customer frequency is there to purchase a particular item set. Okay, so now we have to find the candidate generation using a priori algorithm. We have to remember we have 6 transactions and we have minimum support as 2. So step 1, we have to list down all the transactions. So there are 6 transactions. So we will say n is equal to 6 and we will list down all the 6 transactions. In step 2, we will find the frequent item set, that is L1. So we will be counting how many distinct items are present in our transaction. So we have 5 distinct items, that is I1, I2, I3, I4, I5. Sometimes the item name will be given to you like milk or butter or cheese, like that, or sometimes the item names are not given, they are represented using the numbers like I1, I2, I3, I4, I5. So over here we have to count I1 is present in how many transactions, I2 is present in how many transactions. That is the step 2. We have to find the frequency of the item set. So let us check in our transaction I1 is present how many times. So you can see it is present in the first transaction, I1 is present, then it is present under the second fourth transaction, it is present under the fifth transaction. So it is present 3 times. So we will write I1 is equal to 3. Similarly, I2 is present in how many transactions? So we can see I2 is present in the first transaction, I2 is present in the second transaction, I2 is present in the third transaction, I2 is present under the fourth transaction, and I2 is present under the sixth transaction. So that means I2 is present 5 times. Similarly, the remaining items are present in how many transactions we will be finding. Let us check for I5. I5 is present in the first transaction, I5 is present under the second transaction, and I5 is present under the last transaction. So I5 is present 3 times. So that's why I5 is equal to 3. We have a minimum support as 2. So we have to check whether all items are greater than equal to 2 or not. That will become our first item set. So we have I1 with a support as 3, we have I2 with a support as 5, I3 is equal to 4, I4 is equal to 4, I5 is equal to 3. That means all the items is having a support count more than the minimum support count. If it is less than, then we have to delete that item. But in our case, all five items are having support greater than equal to 2. So that's why L1 is equal to all 5 items. Step 3, we will generate the second item set and we will check the support count. So let us generate the second item set. Second item set means now we will combine 2 items at a time and we will check what is that support count. So we are combining I1 with I2, I1 with I3, I1 with I4, similarly I2 with I4, I2 with I5, I3 with I4. All combinations you can give, all distinct combination you can give. I1, I2 and I2, I1 are one and the same. So that's why we don't have to repeat it again. Now I will check for first one I1, I2. In how many transactions I1 and I2 both are present. So you can see in the first transaction I1 and I2 is present. Similarly, you can see I1 and I2 is present under the fourth transaction. So I1 and I2 together they are present only in 2 transactions. So that's why I1, I2 count as 2. Similarly, you can find for the remaining. Let us check for I4 and I5. In how many transactions they are present. So you can see I4 and I5 they are present in second transaction and I4 and I5 that is present in the sixth transaction. Otherwise I4 and I5 are not present together in any of the transactions. So that's why I4 and I5 count as 2. Let us check for one more I2 and I4. I2, I4. So I2, I4 is present in the second transaction and I2 and I4 is present over here also in the second transaction and I2 and I4 over here also it is present under one transaction. So it is present how many times? 3 times. So you can write the count in which both the items are present. So over here also we have to check only those item set which are having the frequency count more than 2, remaining we have to remove. So L2 that is the next item set we have formed only with those combination those are satisfying the minimum support count as 2. So over here you can see I have just included only those item set which are having the frequency count more than 2. Remaining all I have already removed. So you can see L2 is equal to I1 I2, I1 I4, I3 I2 I3, I2 I4, I2 I5, I3 I4, I3 I5 and I4 I5 because their support count is greater than equal to 2. So that is our second list we have generated. Step 4, now we'll generate 3 item set and we'll check for the support. So we have to combine the item set. How we can combine? Using this list only, the L2 list only, we will now combine the 3 items together in a set. So we have included different combination over here. So we can see I1, I2, I4. In how many transactions they are present together? They are present only in one transaction, I1, I2 and I4. So let us check I1, I2 and I4. I1, I2 and I4. I1, I2, I4. It is present only, you can see only in the fourth transaction. Otherwise they are not present together. So that's why the support count is only 1. Similarly, we have checked for the remaining items. Let us check for I3, I4, I5. So I3, I4, I5 is present under the second transaction. I3, I4, I5 is present under the sixth transaction. So that's why the support count is 2. Similarly, I have checked the combination with different items, and you have to list only those item set whose support is greater than equal to 2. So we have only 4 item set whose support count is greater than equal to 2. So that is our L3. So we have 4 items. Step 5 will generate 4 item set and we'll check the support of it. So you can combine 4 items. So I have combined I2, I3, I4, I5. You can combine any 4 items and you can check the support count of it. This combination you can do using the previous one. So you can see in the previous one I1 is not present. So that's why I have not included I1 over here. So this combination depends upon the previous result. So that's why I1 we cannot include it. So I2, I3, I4 and I5, that is what the combination is. And we have to check in how many transactions they are present. So I2, I3, I4, I5 are present in 2 transactions. You can see in second transaction and in sixth transaction. So that's why the support count is 2. It is also satisfying our minimum support count. Our minimum support count is 2. So we have to check the item set is greater than equal to the minimum support count or not. So yes, it is greater than equal to. Now if I will generate the fifth item set, I cannot generate it because I1 is not having that much support along with the other items. So that's why I cannot generate the fifth item set. I have to stop here. No more candidate support is present. At the end, I will be writing the final frequent item set. So if I will be doing only individual item set, this is L1 I can form. L2 is nothing but the result of combining 2 item set. L3 is a result of combining 3 item set and L4 is a result of combining 4 item set. I can go only up to L4. I cannot go up to L5 because I1 I cannot combine with any other item set because it's not having the minimum support count greater than equal to 2. So that's the solution you have to write. So that's about the algorithm. Thank you all of you. If you like the video, you can click on like button, and to view such type of videos, you can click on the share button.